Children, we will start with the second chapter of geography, that is physical features of India. Children, as you know, India has a rich and varied landform. So we have plains, we have hills, yes, we have plateaus, we have islands, we have mountains, and we have deserts. Okay, so we are going to learn all these features that we have in our country, and we will see also the evolution of such features. Now, what are we going to study in this chapter? We are going to study about the Himalayan mountains, the Indian desert, the northern plains, the peninsula plateau, and the coastal plains. Okay, the western coastal plains and the eastern coastal plains, the islands, the two islands that you can see, Andaman Nicobar Islands and Lakshadweep Islands. So we'll look into the details of all these physical features and see how they were formed. How was the Indian landmass formed along with all these features. Children, before I go ahead with the chapter, let us recap what is there inside our earth. You have learned this in class 7, I think, what is there inside our earth. So you can see here, I have shown you, this is our crust. Yes, the thinnest layer of the earth where we live and where there are oceans. Then we have the upper mantle, the outer core, and the inner core. These are the layers of the earth inside our earth. This is a portion, it's like a cake piece. Okay, when we cut a cake, we take out a piece, we see all the layers. We see the creamy layer, the cake layer, and the other kinds of creams that are put in. So we can see all the layers once we cut the cake. So this is a cake piece taken out from the interior of the earth. It's just to help you to understand what are the different layers of the earth. So here, which is the hardest layer, it is the thinnest layer. After that we have the upper mantle, then the mantle, outer core, and inner core. Now to understand this better, let me show you this diagram. So you see here the crust. There are two types of crust. We have continental crust and oceanic crust. Okay, so this forms the crust. Then below this there is upper mantle. You can see upper mantle, as I told you, which is slightly hard. Okay, the little few kilometers is slightly hard. This is called as the lithosphere. The entire crust and little part of the upper mantle is called as the lithosphere. Now below the lithosphere is a semi-molten kind of a layer which is called as the asthenosphere. Okay, semi-molten. Okay, that means it is slightly liquid. It's not hard like the crust. And then we have the lower mantle, and the entire thing is mantle, but this is divided into upper mantle and lower mantle. Upper mantle, as I told you, certain part is still hard, which is called as a lithosphere, and then there is below this a semi-molten state kind of a layer in the upper mantle, which is called as the asthenosphere. Then we have the mantle again in a molten state. Then we have outer core in again very hot temperatures and in semi-molten state, but the inner core has become solid due to the pressure of these layers. The inner core is solid. Okay, so we have two types of crust. You must remember, continental crust and oceanic crust. Under the ocean also there is crust, hard layer. And then we have upper mantle and lower mantle. Upper mantle, you can see there are two parts to the upper mantle. It is one is the hard layer, which is called as the lithosphere, and this is the semi-molten layer, which is called the asthenosphere. Now you see the entire crust and lithosphere is actually floating on the asthenosphere. This is a semi-liquid state. Okay, so it's floating. Okay, it's floating on this. So I'll just show you further. So the mantle is the layer of the earth just below the crust, and it is made up of liquid. It's not liquid, semi-liquid. Because of the mantle is liquid, the hard surface is actually floating. The crust floats on the mantle is similar to the crackers floating on the top of the soup. So when you order tomato soup or any other soup, and we put those bread pieces over it, the fried bread pieces. They're called as crackers. What do we see? They are floating on it. So similarly, this the tomato soup is actually the mantle, and these crackers are the earth's crust, which is broken into pieces. So they are floating. Now, to understand this better, you must have see here. You must have gone on a cruise or on a boat ride. So what do? The boat cannot come near to it, so they put a plastic kind of a bridge, okay, and then you have to climb the boat. So when you put your legs on this, doesn't it shake? Yes. So this is actually the hard crust which is floating on the mantle, which is liquid or semi-liquid state. So children, you can see the entire crust, which is broken up into 7 major pieces they are called as plates, and they are floating on the asthenosphere. Okay, this is in a liquid state. They are floating. Although you can't see, this movement is very, very slow, but because of this movement of the plates because it's floating on the asthenosphere, lots and lots of landforms are formed, which we'll be learning today. Now children, as I told you that the crust and the lithosphere is floating on the mantle, which is the asthenosphere. It is in a semi-liquid state, and this is very, very hot, due to which there are convectional currents. Now what are convectional currents? Now you must have learnt it in science. Have you seen when you put a pot to boil, a pot of water to boil on the gas, you can see then bubbles come up, and then they come up and again go down, again come up and again go down. So this kind of currents are taking place in the asthenosphere. Okay, due to this currents, they make the plates move, and since the plates are broken up into 7 pieces, they keep moving from place to place. Okay, so you see children, here our earth's crust is broken up into 7 major plates or pieces. You can see they're called as plates, or these plates are also called as tectonic plates. Okay, so which are the 7? You can see here, the names are given: African plate, North American plate, South American plate, African plate, Antarctica plate, Indian Australian plate, Eurasia plate, and small others as Caribbean plate, Nazca plate, and Philippines plate. So it is all broken up into pieces, and these pieces are floating on the mantle, that is the asthenosphere, which is in a liquid state. And due to the conventional currents, and how are these conventional currents caused? Because of the heat inside the asthenosphere, they constantly make the plates move. That is, these lithospheric plates, they move. Okay, but the movement is very slow, maybe 1 inch per year. It is very, very slow, and we do not feel it. So but these movements take place due to the conventional currents, because these are floating on the asthenosphere or the mantle, which is in a semi-liquid state. Now children, as I told you, in the mantle, which is in a semi-liquid state, there are currents formed. Because it's hot and leads to convectional currents. It's like water boiling in a pot. You can see it's going up, then it comes down, again goes up, comes down, again goes up, comes down. So this is constantly happening in the mantle, due to which the plates, the earth's crust, which is broken up into pieces, the pieces are called as plates, they keep moving. Okay, and there are 3 types of movements. Okay, plate movements. Earth's plates can move in 3 directions. One is, you can see, is a divergent. They are moving in opposite direction. This is moving this side, other is moving to the right, this is moving to the left, and you can see the gap being formed in between, which then gets later filled with water to form a rift valley. A rift V kind of a shape is formed. Then we see convergent movement. What is convergent movement? Then 2 plates are coming close to each other, and whatever, now you can see the gap in between, there are sediments lying, which gets pushed up to form mountains. And the third kind of movement is called as transformational, which leads to earthquake and volcanic activities. See, they are sliding past each other. Can you see here? They're sliding past. One is going up, one is coming down. And due to this friction, what happens is earthquakes takes place, and through this also molten lava comes out, which we have volcanoes. So there are three types of movements which take place, and because of the convectional currents. Okay, you must remember this. Children, what we just learned about the movements because of the convectional currents, these plates move in different directions. I've already told you divergent, convergent means coming close to each other, and transformational movements. Okay, so all these are actually the theory of plate tectonics. Okay, so we have learned the theory of plate tectonics. Let us learn another theory which is called the theory of continental drift by Alfred Wegener. Children, according to the theory of continental drift by Alfred Wegener, he said that when the earth was born, there was only one land mass. It was all connected. There was no separate continents. It was only one land mass, which he called it as Pangea. Pangea means all earth, one land mass. And this water that was surrounding it was only one water body, which was called as Panthalassa. Okay. So children, just to recap again, just a reminder that plate movements are of three types. You can see divergent means going in the opposite direction, due to which fault is created, a crack is created in between the two. And then you can see the convergent, where they are coming close to each other and the sediments get risen up, that is called as folding. And then we have transformational activities, which leads to earthquakes and volcanic activities. Please remember these three movements. So children, again I recap what the theory of continental drift. Alfred Wegener mentioned that when the earth was born, it was only one big land mass, which he called it as Pangea, and only one big ocean, okay, only one ocean, which was called as Panthalassa, meaning all water, meaning all land. Pangea means all land, Panthalassa means all water. Okay, and then because all this mass is floating on the mantle, which is in a semi-liquid state, so there and due to the convectional currents, these are constantly moving. Okay, and then he called this as a southern part of this landmass as Laurasia, southern part as Gondwana, and the northern part as Laurasia. Okay, then you can see because of this convectional currents which were happening, yes, it split the Pangea into two parts. That means Laurasia separated, and this Gondwana separated from each other. Okay, so and with this, once it's separated, yes, again due to convectional current, it split the crust into a number of pieces. And what are the continents formed with the splitting of the Gondwana land? We have South Africa, Africa, India, Antarctica, and Australia. And with the splitting of Laurasia, we have North America and Eurasia. That means Europe and Asia. So continents were formed. Okay. So you see the convectional currents split the crust into a number of plates, and after the split started moving in different directions, and you can see the Indo-Australian plate drifted northward and collided with the Eurasian plates, and because of this further more features were formed. So you can see here after the split, it split into many parts because of the cracks that were formed. So you can see here, this was the Gondwana land which split, and you can see India moving northwards. And then where is it going? Yes, it's moving northwards and hitting the Eurasian plates, getting stuck to this Eurasian plate. Okay, and I'll show you a video on how this was drifting and how our present continents look like. Children, now let us have a look at the animation of the splitting of the Pangea and then the formation of the Indian landmass. Okay, so just enjoy this video. Just see how Indian landmass is formed. This is the theory of continental drift due to the convectional currents or the theory of plate tectonics. So you can see India here, yes, moving ahead to collide with the Eurasian plate. Can you see? Just watch it carefully. And that's how our India was formed. Our Indian landmass was formed. Yes. So this is how our present continents look. So you see children, the convectional currents split the crust into a number of plates, and after the splits the plates start moving in different directions, okay, because of this convectional currents. And you can see the Indo-Australian plate drifts towards the north and collides with the Eurasian plates, and further many more features continue to be formed, okay. So we will see here the collision. You can see here the Gondwana land broke up, and you can see India moving ahead, yes, and it's colliding with the Eurasian plate, and that led to the formation of our Indian landmass.